Now let us see the cost of mismatch of combining these two verticals in a system. So all the times an application programmer has to call the database to store something and retrieve something. For calling these databases, generally we use a SQL, structured query language. So generally these SQL queries will be embedded into the application programming and then will be shooted through a driver. You can call a JDBC driver. For MySQL there will be a JDBC driver, and for Oracle there will be an Oracle driver, Oracle JDBC driver. So these drivers generally carry that data towards the database, and database will execute those statements and do respective things. Like, using SQL you can use a data definition language, DDL, and data manipulation language like CRUD operations, create, read, update, delete. So you always have to shoot the queries using JDBC to the database. And one more thing, all you have to do to maintain the concurrency and to maintain the integrity of the data and all those things, you need to work on the transactions, you need to work on the concurrency, you need to work on the caching, you need to work on the connection pooling, and a lot of other jargons are there. So one of the major problems generally developers tend to get involved with when you're programming with JDBC is that almost 45% of the code will be involved into the data access layer. So that means they have to be very conscious about the querying the database, the performance of those queries. Then it's also important that they are closing the transactions, they are committing the transactions at the right point, and once an exception occurs, they have to roll back the data. And then they should also have a very good logging, they should also maintain the logging in the particular catch blocks of the exception. But JDBC API has got a weak exception handling mechanism. All you can find is three kinds of exception, known as SQL warning, SQL error, and data truncation exception, which are actually implemented as in checked exceptions. So every developer is forced to write the catch blocks for them. And obviously when these kind of exceptions occur, there's nothing but a programmer has to come back and rectify something and refresh or restart the application. So there is nothing one can bounce back using catch blocks, but still they have been forced to do that. Whereas when you take the object relational mapping frameworks like Hibernate, they have went on to declare all the exceptions as runtime exceptions, where you don't really need to write even a single catch block. So let us see what are the advantages of object relational mapping and how they are going to be useful for us. And I will elaborate more detailedly about Hibernate and what are the advantages it gives when you compare to writing the programs in JDBC to access the database. So if you look at the object relational mapping, they say it's about mapping the objects and tables. CRUD operations will be done by the ORM framework, and it has got a wonderful concept of lazy loading, and it has got a first level caching, which is going to give you a wonderful performance, and it also gives you a vendor independence. So when you talk about the object relational mapping, the total concept is all about the data what you have in an object should be stored in a table. So it's all about mapping the object fields, the properties, to the table columns. So once you give an object to ORM framework and tell it this data in this object has to be persisted, the object or relational mapping or Hibernate framework will check out what table it has to be stored into depending on the configuration. You can say it as an Hibernate mapping file, HBM file. So it understands into which column a particular field has to be stored, and it generates a SQL and shoots the query. So whatever you have, the primary key on the object side will also be stored, or it will be generating a new primary key in terms of kind of primary key sequence or a high-low concept or whatever it is. So this is one thing. And remember that when you're fetching the data from the database to the application, object relational mapping uses a concept known as lazy loading. So unless until for certain kind of concept, unless until you use that object in the application, the real object will not be fetched out. So you will be given just a proxy That means the SQL will not be shooted unnecessarily. This actively happens in terms of a collection. So it will not retrieve the whole set of bunch of objects without using them in the application. So this saves a lot of performance and a lot of queries to the database. And when it comes to storing the multiple objects, Hibernate ensures that the lock time on the tables are minimal, so that the performance of the accessing the database is going to be very high. So the second thing, the important thing about object relational mapping is also about first level caching. Say for example, I have already retrieved an object with a primary key of 25, and I am again somewhere shooting another query asking it to retrieve an object with the primary key 25. First, Hibernate checks out in its first level cache that whether it has already retrieved an object with 25 or not. If it is already retrieved, it's just going to give you the reference of that object and tells you to use it. So this saves a lot of performance in terms of unnecessary shooting of the queries, and Hibernate shoots the real performance oriented queries and all. So you can see them even in terms of when you check out the logs of the Hibernate. Seriously, it is going to show you the kind of SQL queries it is going to generate. So there are a lot of advantages, and one more biggest advantage what Hibernate gives us is that it's a database independence. All you are going to do is that you are going to configure the details of a database in an XML, and when you're going to change the database, switch the database from one, say Oracle, tomorrow you're going to shift between MySQL to Oracle, all you have to change is an XML, and your application is going to get ready to communicate with that database instantly. So it's all about the configuration file for you. So you always have an independence to switch between the databases within no time. So when this happens because Hibernate tries to Hibernate uses ANSI SQL, which is standard for every database. So it does not use a specific SQL syntax which is specific for Oracle or specific for a particular database. This gives you independence to switch between the databases. So that's one of the biggest advantages. Hibernate gives you a flexibility of maintaining the collection pooling, which has got C3B0, wonderful open source framework for managing the connection pool, and then it has also got provision of giving the second level caching, that you can use a physical memory to cache the particular objects and tables so that faster retrieval of these things happen. And you have got a lot of advantages. So we will be seeing each and every advantage of Hibernate when you start covering it. Hibernate is an open source framework, lightweight, and it does not really need an application server to run it, as if you have got EJB, which needs an application server like WebSphere, WebLogic, and JBoss. To run Hibernate, you don't really need this kind of very hefty application server. All you can go ahead with Tomcat web server, very simple web server to run your powerful application. You have got first level caching and second level caching, and if you see the Hibernate components, the most important, I'm mentioning the most